What has happened? No purchase 919 actual, computer has predicted 829 correctly. Purchase out of the 43, 81, computer has predicted 38 correctly, it has improved. But 43 it went wrong. So out of the 83 people, 81, it has correctly predicted 38. So prediction if I take 128 the computer has predicted, out of which 38 people only bought. This is the prediction column. 90 plus 38 is 128 people bought the book. Then here you have 90 coming here. So 38 only will bought means the probability 38 by 128. 90 by 128 it has gone wrong, and therefore if I now evolve a question here, strategy 1, mail it to all the 1000 people, you mail it. What happens? If you mail it to all the 1000 people, how many people bought, sir? 81 people bought. So 81 into $6 plus minus $1 loss for the remaining 919 who did not buy, there is a loss of $433 if I mail it to all. The second strategy, take some tomato soup, keep quiet, don't mail it to anybody, $0. It doesn't help. It doesn't help. The third one, if I use the logistic regression output which predicts 128, I mail it to this 128 people with the probability of 1 by 7 which is there. Then how many people bought actually out of the 128 predicted? Actually 38 people only will have bought. So now 38 people bought, which I put $6, 90 people did not buy, a minus $1. Overall I gain $138, which has, in spite of the rather moderate or the goodness of fit of the model, it has substantial practical value to the mailing strategy of the book mail company. Are you with me? Hence logistic regression. It is not the classification matrix alone, it is not the predictive accuracy alone, it is not the significance of the predictor variables alone, it is not the odds alone, but it has the practical substantial value to the company, a targeting a particular type of people. You predict this is the target which will buy, target marketing, mailing strategy can be beautifully evolved by logistic regression. $138 is the expected profit. You may say type 2 error and all that, but it has got a value. That is why people use explanatory power and ability to strategize. Yes, sir. Yeah.
So, can the holding data be historical when it is available?
Well,
how will we create training data if it is
yeah,
a new product?
yeah, I will tell you. If it is a new product which is no data, new product no data means you will have to think of some unsupervised learning. Is a new product no data is not perhaps possible. Now, I will put a question to you. The classification techniques such as discriminant, multiple discriminant model of Fisher or logistic regression, or these two we take, we first use the data that is currently available, past data or whatever you may call it, up to the date it is available. If you have got a cell phone company data on 8 variables to predict market churn, let us say you have got 20,000 records. Now this 20,000 records is not too much of a distance past, but this is available, let us say in the last 1 month, this is it. Let us assume the pattern is not going to significantly change in the next 1 month, maybe 6 months. So what I do is I divide this into 70-30 or something, 70% for the training and 30% for the test data. Then I test it. How the model works, first I train, then the 30% whether it has worked well. Then I do not stop, I test it with the new data, a new record comes, how do I predict? So this is supervised learning. Unsupervised learning, I do not worry about dependent or independent variable, I form some clusters. Deep learning, random forest, neural nets and all that. I have no idea about an a priori structure of a dependent variable, independent variable, nothing. I form cluster. Neural network can be a classifier as well as unsupervised learning, both. It can perform the task of logistic regression as well as unsupervised. So, I form some clusters. Once I form the clusters, what do you do? This cluster is socially gregarious cluster, fun loving cluster. Next cluster, it says based on some descriptive measure I do. Once I have a cluster, I use a descriptive measure. This cluster is economy oriented cluster, value for money cluster. This cluster is a price conscious cluster. I have formed this, but before forming I have no idea whether they belong. I have a deep learning. Now I will ask you a question. I got that. A new record comes, tell me which cluster it will belong. These models cannot do. Then you need a logistic, multinomial logistic or discriminant analysis to predict the outcome of the new record. That is marrying the two. From unsupervised, you still need some of the traditional things. And no forecasting is 10% accurate, yet you have to forecast. This is paradox in forecasting, you cannot avoid. But look at this, in spite of a moderate fit, look at the substantial value. If I mail it to all, I lose. I mail to this target predicted by logistic regression, I gain. So, this is what I thought I should give you as an orientation of a power of logistic. If you have some questions, I still have about 7 minutes, I can take it. Yes, sir. I will answer to the extent possible, whatever little I know, I will answer. Yes, sir.
That was a wonderful presentation. There's one statement that I'm going to make, just correct it.
Yeah, please. Yeah.
So in any case, we cannot increase the profit from $138 to $139.
Correct.
Right? This is the maximum that we can do.
Yeah, correct. This is the expected profit.
This is the expected profit, right?
Yeah, true.
And which means we are actually marking the threshold
Yeah.
beyond which
Yeah.
we cannot increase the profit, and beyond, if we go on less,
Yeah.
the profit will
Yeah.
always go down.
Yeah.
So, and when we are speaking about the threshold, which means actually it's actually a relationship between alpha and beta, right? One increases, the other decreases.
Yeah, true, sure, absolutely. Now, in statistics, you cannot simultaneously minimize both. So, it is a trade-off.
So there's an optimization
Yeah,
of
yeah,
the
correct.
alpha and beta, right?
That is what your ROC gives you. Yes, correct. Now, there is another point I want to make here. The important learning takeaway here is you should not mail it to all, you lose. You mail only to the target predicted by logistic regression, even though the accuracy is less, it gives this. And this perhaps is not possible in the black box methods like random forests or neural nets. Explanatory power of logistic regression outperforms the black box methods when it comes to a strategy. That is why our government also in predictive risk models and financial risk and all that, they have still not fully accepted the deep learning. In Flipkart and Amazon, deep learning will do very well, image and all that. Our government, we have tried, RBI, several places they have gone, they say logistic regression, discriminant, something you have, where we have something to fall back, explanatory power. This is a black box neural network. I cannot make the black box into a white box unless I do research on that. Why you cannot do it? Because in neural network, every stage the weight is revised, the bias is revised, it keeps revised. I do not know the final equation in neural network, it is black box. I do not have the equation. Because this last stage is a function of the previous, which is a function of this, some W cube, you will go mad, you can't do that. That is the problem. Yeah.
Sorry,
Yeah.
I am asking one more question.
Yeah.
Basically on this. So this example is a marketing angle where we can accept
Yeah.
tolerances,
Yeah, yeah,
errors.
yeah.
But
Yeah.
from a credit risk perspective,
Yeah.
if it is subscription-based
Yeah.
service,
Yeah.
you are trying to predict the likelihood of a default or
Yeah,
likelihood
correct. Wonderful.
So there, it becomes really difficult
Yeah.
to tell your
Yeah, wonderful. Because I am given only 50 minutes, I have one more example of an actual bank with which I am working, 800 customers on credit card, whether they will be the payer of the dues or not, based on entirely categorical variables. Logistic regression can deal with all input variables categorical. If I start, it will take another 1 hour. I do not have the time, and hence I have not put it in my slide. But that is a valid question, deals only with the bank, credit risk, market risk, operations risk. In a bank, credit risk is NPA, non-performing assets. And you know, thanks to Raghuram Rajan, how many banks have reported that, and bank shares have plummeted, you know all that. So that is something I have done a model. I have also got a logistic regression model to deal with the interaction in a depression study from the Berkeley data set, and their logistic regression is used, and therefore these are only examples. I am not saying logistic regression is used only here, but given the 15 minutes time, this is what I thought I could share with you. Thank you for the time. If you have any question, welcome. Yeah.
So, in the case like when you were saying that product, brand and shopping, so the two variables which came out to be insignificant, isn't it that like we should also look at whether there is any multicollinearity between the two?
Yeah, that is true. So the limitations of logistic regression will be similar to the regression. Multicollinearity, input variables or independent variables are highly correlated. But I will put a counter question to all of you. Multicollinearity, how do you address? You use some factor analysis, principal component analysis and all that. But you have not ignored, you have not addressed the individual variable. Which variable? What is the problem of multicollinearity? Take a bank, advances, deposits, investments, income, all are highly correlated. So I cannot say whether advance is more important than income because of the amalgamation. Now, if I do a factor analysis, I have converted the correlated thing into uncorrelated factors, but I will say this factor does this, but I still cannot say which individual variable is more important. You never know. In that sense, I feel multicollinearity is also highly exaggerated. If you do a factor analysis, you say this is a factor, but this factor, my dear friend, is influenced by the